Hello, math, big kid math. We are looking at Pythagorean theorem. I realized I don't have a video that I filmed yet that actually talks about the difference between the theory and the formula. So this is not the focus of this video, it's how to use the formulas. So the big thing with Pythagorean theorem is the theorem is a squared plus b squared equals c squared. In real language, what this means is that the area of the sum of the legs. So if this is my A, my B, my C, this is the leg that's A. We're talking about the area of the sum of the legs. So A squared plus B squared is going to be equivalent to, remember this is going to be B squared here, and the a squared would fill in the rest of the c squared. So it states that the sum of the square of the legs of a triangle are the ones that are right next to the 90-degree angle. Okay, they'd be the sides of a square. Remember, all of these rectangles and squares are, we cut them in half, we get a triangle. Okay, so that's what we're talking about here. The leg, hypotenuse. Okay, now this is stuff we talked about in class, so as I said, I'm not going to go into that too much in depth right now. But the problem with the theorem is that we're solving for c squared. We don't want the area. So traditionally in math, we don't solve a formula. We don't solve something until we know exactly what it is we're going to solve for. So we have two different formulas, and you have this fancy sheet, this one right here. It's even in D2L, that has your formulas in it. This week, I want you, my pen just went flying. I want you working with the formulas this week, all right? So there's two formulas. The first one is C equals the square root of A squared plus B squared. Now, if you look carefully, you can see the theory within that. So I'm going to model what this looks like. Now, a lot of you are like, I don't know what to do. This is like any other kind of geometric formula. We're going to identify the variables. We're going to plug them into the formula. That's the answer. Don't overthink it. So if we have a triangle, and I'm going to use easy ones, we talked briefly about those Pythagorean triples. So this is 3 centimeters, this is 4 centimeters, and this is my unknown, or x. So the very first thing we do is we're going to label. A and B are the legs. A, B. C is always the hypotenuse, the one opposite the 90-degree angle. All right. Now, you're going to start your work by labeling, well, you should also put what number you're doing. Okay. A equals, B equals, C equals. Over here, A equals 3 centimeters. B equals 4 centimeters. C equals, I don't know. I have no idea what C is. That's what the formula is for. So that's what we're going to use it for. All right. Once I identify this, I go over to the side and I write my formula. If you're not sure which one to use, notice how this one says C equals. Well, up here, I don't know what C is. So that's what we're going to use. A squared plus B squared. I always keep the square root there. Okay? Just like in order of ops, I do one step at a time. And this is where we substitute. So my A is 3. So I'm literally going to drop that A into here. Now in this, it says that I'm going to square 3. So I square 3. B, 4, put it in. 4 squared. Now I don't have any other unknowns here. So now it becomes an order of ops problem. The other thing to keep in mind, pro tip, anything under a radical, we can pretend it's in brackets. So I have to get that done first. So now we run this. 3 squared, not cubed, is 9. 4 squared is 16. C equals the square root of 25. Now you go to your calculator. Some of you are going to hit the square root button and then 25. The way you know is that if the square root shows up on the screen, you put it in front. If not, you have to do 25, then push the square root button. So the square root of that is going to be 5. I put it into my diagram or into my little thing here, centimeters, because C must be the longest side. So is it the longest? Yep. Okay, good to go. So that's how you do if you don't know the hypotenuse. Okay, that's when we're solving for the hypotenuse. Remember, you're on video, you can pause, you can go back. All you need to do is do that same structure, but put in the different numbers. And some of them are huge. Grade 9s, you've got numbers that are up to like 56 squared. Those are big numbers. Doesn't change anything. They're just big numbers. Doesn't matter. Now the next one is the inverse. Inverse Pythagorean theorem. This is when we have a problem that looks like this. We have 3, I don't know down here, and we have 5. Okay? Doesn't change anything. We start the same. We're going to label it. I always recommend that you make A your unknown, because that's how I write the formulas. Your choice though. So A equals that, B equals 3, and C equals 5. Now you'll notice that it is a leg that I am missing. So let's write it down. A equals, I don't know. Is that okay? Yeah, because that's what this was all about. B equals 3, and C equals 5. What do you see? I am missing A. Do not use the C equals formula if you are missing A. So again, the theory on this we talked about in class. The reason we take C squared minus B squared is we know the area of the hypotenuse. We know the area here. This is the opposite of A squared plus B squared. Right? So this is why we have to take the bigger area and subtract the smaller area. All right? Again, not going into theory, that's what class was about, but this will give you the technique. So what do? I don't know A, I keep writing it down. By the way, if you don't have this written down, then your notation isn't quite correct. So do exactly what I'm doing here. Okay, that's what geometry is just applying formulas. So C squared, well that's down here. So I'm going to take my C squared. 5 squared. Watch carefully. Minus. Must be a minus. Well, B is 3, so that's going to go into my formula. I substitute it into my formula. Next line is B equals 25, which is 5 squared, minus 9. Bada bing. Good. A equals the square root of 16. Bada bing. Last thing I do is I take the square root of 16. A equals 4. I put it back in my little number list here. 3, 4, 5. Makes sense. It's all good. Right? For grade 9s, if I end up with something that's the square root of 90, okay, this is where, if you want, you can go 2 times 45. This is 5 times 9, which is 3 times 3. There it is. See how I have 2? Oh, you can't see. There we go. If I have 2 of the same prime factors, what do? They come out of the square root. So this would be 3 times the square root of 2 times 5 times 9. No, 2 times 5. 2 times 5 is 10, so you get 3 square root 10. Okay, grade 9s, I'd like for you to do that. If you can't get there, no big deal. And grade 8s, don't even worry about that. It's called simplifying radicals, grade 10. And grade 8s, you're good. Grade 9s, there's only one other thing that you can do. And that is proofing a triangle. So if they give me 3, 4, 5, what's weird? They've just given me every single measurement on the triangle. What they're going to do is I'll put a little question mark. They want us to prove that this triangle meets the Pythagorean theorem. So I don't like the theorem when we're solving lengths, but when we're proving triangles, that's when we use it. So in this case, we know A, B, and C. A, B, C. This could be B, A, C. It doesn't matter which of the legs is which. Never does. So I'm going to write down A equals 3, B equals 4, C equals 5. We know this is going to work, but we'll do it anyway. Should we make it interesting? Let's make it 6. Okay, so this is 6. So what I end up having here is the theory. Okay, so the theory is a squared plus b squared equals c squared. All right? Now, sorry, that's you right there being loud in the hallway. So now I put in my numbers. I get 3 squared plus 4 squared equals 6 squared. Keep solving. Now I'm going to get 9 plus 16 equals 36. Well, 9 plus 16 is 25. So, as you can see here, does 25 equal 36? The answer is no, which means that this is not a right triangle. If I got 25 equals 25, then that is actually positive for the Pythagorean theorem. All right? So that's it. That's your homework. That's what I'm looking for. Okay? The specifics are on the announcements, but I hope that helps, and that's how we use the formulas versus the theory.